Solve the equation matrix A times vector x equals vector b using the LU factorization of A. So here we are given our LU factorization. We have this matrix A is equal to our lower triangular matrix L multiplied by the upper triangular matrix U. And so to get us started here, let's recall that to solve a homogeneous equation by the LU factorization of A, we need to first solve the equation with our lower triangular matrix times vector y equals vector b, and then use that vector y to solve matrix u times vector x equals vector y. So the first thing we're going to do is solve the matrix equation L times vector y equals vector b. So to do this, we want to row reduce the augmented matrix L with vector b to the augmented matrix with our identity matrix in I3, vector y. So we have 1, 0, 0, minus 1, 1, 0, 3, negative 5, 1. And we are augmenting this with vector b, which is negative 4, minus 6, 43. And we're starting with our first pivot here, and we want to use this pivot to eliminate the entries below it. So we'll do the first row plus the second row to give us that new second row, and then we'll also do minus 3 times the first row plus the third row to attain the new third row. And so this leaves us with the equivalent matrix 1, 0, 0, negative 4. We then have 1 minus 1 is 0. 0 plus 1 is 1. 0 plus 0 is 0. Minus 4 minus 6 leaves us with negative 10. And then minus 3 plus 3 is 0. 0 minus 5 is minus 5. 0 minus 1 is 1. And then we have positive 12 plus 43 to give us 55. So our first column is all set, and we move to our second pivot. We want to use this to eliminate the entry below it. So we have 5 times the second row plus the third row to get our new third row. And so this is equivalent to the matrix 1, 0, 0, negative 4, 0, 1, 0, minus 10. And last but not least, we have 0. 5 minus 5 is 0. 1 plus, or 0 plus 1 is 1. And then we have minus 50 plus 55 to leave us with 5. So we have our row reduced form, or row reduced echelon form, and we can see our solution vector y is defined by the components negative 4, negative 10, 5. So we have our solution for vector y, and we're going to now use this to solve our second equation. So step 2 here, we want to solve the matrix equation, matrix u times vector x equals vector y. And to do this, we are going to row reduce the augmented matrix u with vector y to the identity matrix augmented with vector x. And so plugging this in, we have our matrix U, which is 2, negative 5, minus 3, 0, minus 3, minus 1, 0, 0, minus 1. So there is our upper triangular matrix, and this is augmented with that vector we just found, negative 4, negative 10, 5. And so we are ready to start row reducing here. So looking at our third pivot in the third row, I'm simply going to scale our third row by minus 1, which leaves us with 2, minus 5, minus 3, negative 4, 0, minus 3, minus 1, negative 10, and our third row is now 0, 0, 1, minus 5. And so using that third pivot here, we want to use it to eliminate the entries above it. So we'll have 3 times the third row plus the first row to attain the new first row. And we'll also have our third row plus the second row to attain the new second row. So this leaves us with the matrix 2, -5, 0. And we have minus 15 minus 4, which is minus 19. We'll then have 0, minus 3, 0. And we have -5 minus 10, which leaves us with a minus 15. And the last row is still 0, 0, 1, -5. And we notice we have a scalar multiple here in our third row, or excuse me, our second row. So let's reduce this or scale this by a factor of 1/3. And give ourselves a little bit more room. So we are left with 2, -5, 0, minus 19, 0, 1, 0, positive 5, 0, 0, 1, -5. So using our second pivot, we use this to eliminate the entry above it. So that's going to be 5 times the second row plus the first row to attain the new first row. So performing the row operations here, we're going to have 2, 5 minus 5 is 0, 0. And then we have 25 minus 19, which leaves us with 6. Second row is still 0, 1, 0, 5. Third row is 0, 0, 1, -5. And looking at our first pivot here in the first row, first column, we can scale our first row by a factor of 1/2, which leaves us with 1, 0, 0, 3, 0, 1, 0, 5, 0, 0, 1, -5. So we have echelon form, and this is equivalent to our solution vector x defined by the components 3, 5, -5. And so this is our beautiful final answer here. And as you're practicing at home, I encourage you to check by substituting vector x back into the homogeneous equation to make sure that it's equal to vector b.